This is Professor Pelton. This is Trigonometry Chapter 1, Section 2, Part 2, which is on speed. So the first is angular speed. Angular speed is the angle that it changes over time. So what's the angle that you changed here? So let me get the pen working. So the angle has to be in radians, right? How much you turned over a time period. And that time period can be seconds, minutes, hours, years. Doesn't matter how long it's a time period. But what specifically has to be true is the angle has to be in radians. Okay, so angular speed is what you spin over time. What you'll notice is we go back and forth between the words speed and velocity throughout the lessons, and that's because the only difference between speed and velocity is velocity has direction. Speed doesn't. So as a result, speed is always going to be positive answers, whereas velocity can be positive or negative because you can go back and forth within two directions. So we use either or, but the same formula is consistent either way. Okay, so first problem, a fan rotates at 100 RPM. So we don't care the size of the fan. All we care is the center part spun at 100 RPMs, and RPMs stands for revolutions or rotations per minute. But I'm going to use the revolution label to minutes. So 100 revs per 1 minute is equivalent to 100 RPMs. But again, we always want radians, not revolutions. So 1 revolution is 2 pi radians. So that'll cancel, and that'll give me 200 pi radians to 1 minute. And that is an angle over time. So that is, in fact, the angular velocity, which you can get the decimal answer if you want, of that fan. Okay, let's do a few calculations now. Alright, so the fan rotates at 5 pi over 6 radians in 0.5 seconds. We want the angular velocity and the RPMs. Okay, so R, so we got I and II. Okay, so the first one's angular velocity. Angular velocity, which is the funny W from the Greek alphabet, is the angle over time. The angle here is 5 pi over 6 radians over 0.5 seconds, but you want to have all numbers as fractions. So that's 1/2 seconds. We want to make a proper or improper fraction now. Get rid of the complex fraction. So we're going to multiply by 2 over 2. So that cancels there. That'll give me canceling that. So it'll give me 5 pi over 3 radians a second. And that, in fact, is an angular velocity because it's an angle over time. But we also want the RPMs of this fan. So 5 pi over 3, and I'll write it in proper ratio, which is radians over seconds. And again, for RPMs, we want minutes and we want rotations or revolutions, but I don't have either of those. So I can choose to swap either one first. I'll do the radians. So it's 2 pi radians to 1 revolution. And we can cancel the rads, cancel the pi's. So we have 5/6 revolutions per second. But again, that's still not RPMs, because RPMs is minutes, not seconds. So we need to multiply by 60 seconds to 1 minute. So the seconds will cancel now. So the 60 over 6 gives me 10. So that's 50 revolutions to 1 minute, which is the 50 RPM, which is our final answer there. You can do the calculation in 1 step or 2 steps on that. I chose to do it in 2, just for the sake of the lesson. Pause the video and try the student problem. Make the same recommendation here as I did before. Always work with fractions. No decimals, no mixed numerals. So 33 1/3. 33 times 3 is 99 plus 1. So that's 100 over 3 revolutions per minute. That is the equivalent for 33 1/3. And again, we want an angular velocity, so that's going to be in radians, not revolutions. So 1 revolution is 2 pi radians. Cancels there. So that gives me 200 pi over 3 radians a minute. And that is an angle over time. So that, in fact, is our angular velocity. Okay, so that's angular velocity. Let's go to, angular velocity or speed, however you want to look at it. In the next page, we'll go to linear speed. And again, same thing here, linear speed or linear velocity, same thing. The only thing difference is the velocity has a direction, whereas the speed does not. Okay, so here the formula, which they use the v for the velocity, is s over t. Again, this is the time. And that, of course, is the arc length from s from the previous formula, right? Arc length. And typically you're used to seeing distance over time, but if you think about it, s is a distance. The only thing different here is we want an arc length because we're working in trig on circles. That's the only real difference between that and the Algebra 1 formula you used. Okay, so you have a turntable with a 3 and a 5-inch wheel here. And the outer one spins some distance, and the inner one spins some distance. Okay, we don't know what that distance is. They both spin 120 degrees. Again, the problem is we can't use degrees, so we have to multiply by pi over 180. And the degrees cancel there, and that'll give us a radian answer, which will be 2 pi over 3. And that is the same angle for both. So both of these spin at 2 pi over 3 radians of the angle. Okay, so we have the 3-inch and we have the 5-inch. So the distance traveled is radius times the angle. And the first one had a 3-inch. The second one had a 5-inch. And they both spun the same amount, which is the angle there. 2 pi over 3. Again, don't put the radians in there. So that gives me 2 pi inches there for our length. And this one gives me 10 pi over 3 inches here for the length. So I know the angle that it turned, and I know how far it traveled. So now I can figure out my speed, or linear speed. So my linear speed, v equals s over t. v equals s over t. Well, here I traveled 2 pi inches, and here I've traveled 10 pi over 3 inches. Now I need a time period. Well, the time period in here is 2 seconds. 2 seconds, and 2 seconds. So here I'd get pi inches a second. So that's my final answer there. And then here I got to multiply by a half over a half to cancel that. Leave me with a 1 second. So that leaves me with 5 pi over 3 inches a second. And that's my final answer there. Okay? So take a second, pause, and look at the student problem. Okay, so we can clearly see the student problem asks about angular velocity and linear velocity. Well, clearly, this one is traveling at a velocity, was it pi inches per second? And this one is traveling at a velocity of 5 pi over 3 inches per second. So clearly, the one on the outer edge is traveling faster because it has more distance to cover over that same amount of time. However, they're both turning the same angle of 120 degrees. Okay, so as a result, they have the same angle over the same time period. Therefore, they both have the same angular velocity. So in that case, the 3-inch and the 5-inch angular velocities are the same. However, the linear velocities are not true. In the case of the 3-inch and the 5-inch, okay, those velocities are not equal. The 5-inch is clearly traveling faster because it has to cover more distance over that same amount of time, because velocity is the distance over time, which in this case is an arc length. So it has to have a greater distance than the 5-inch one. Okay, pause and do the next student problem. Okay, a person on a Ferris wheel starts at point 0 and goes to point 1 and travels some distance s. So I want to figure out how fast they were going. So first off, the radius of this wheel is 30 feet. It's a big old Ferris wheel, so that's pretty big, right? And we have the angle, which is 40 degrees, which is kind of a problem. We can't really work with that. So 40 degrees times pi over 180. Okay, so that's going to give me my radian answer of 2 pi over 9. So 2 pi over 9 radians is my proper angle. Okay, so I have my angle, but I don't have the distance that I traveled. I'm not sure how I traveled, but we know the distance arc length is the radius times the angle. And my radius here was a 30-foot Ferris wheel. And my angle I just calculated was 2 pi over 9. And again, we do not need the radian label in any formulas. So that'll give me a nice 20 pi over 3. And that'll be feet because it's a length. Okay, so I just traveled that distance. I know that the angle that I traveled, I know the distance I traveled, so now I can figure out how fast I was going. And velocity equals the arc length over time. And the arc length that I went is 20 pi over 3 feet. And the time period that took me was another 2-second problems, 2 seconds. So I'm going to multiply it by 1/2 and 1/2. So that'll cancel, leave me with 1 second. So that'll leave me with a 10 pi over 3. And the label will be feet per second, which makes sense. That's a speed or a velocity, which is a linear that you went. Okay, that is the end of part 2.